Okay, this is Unit 1, Lesson 4, warm-up. Number 1, which of the following pairs are like terms? Can you add 2x to a 1x? The answer is yes, so that's a like term. You can't add a 2y to a 2x, so that's not. And you can't add a 2x to a 2, so that's not. All right, which of the simplify the following expression. So we have 2x and a negative x. That's it for the x's. So 2x minus 1x is x, and then plus 2 minus 3 is a negative 1, and then 3y's minus 1y is 2y's. So order is unimportant. So you could put 2y plus x minus 1 as long as that the one term is negative. However, whatever order you want. All right, is this equal to this? Yes, I have a positive 2x term, and I have a positive 3y term, and I'm adding them together. So it doesn't matter if I write it that way or I write the 3y first. That is equal to that. All right, how about this one? Is negative 2x plus 3y equal to a positive 2x and a negative 3y? And that would be a no. All right, and this one should say solve. Sorry for the lack of instructions. So let's see, there's my variable, so that means I'm moving this to the other side. So 3x equals negative 10. Isolate my x, so x equals negative 10 over 3. You can always check these. 3 times negative 10 over 3 plus 5. This would be negative 10 plus 5. Negative 5 equals negative 5. So that's good. All right, over here we have to look at the parentheses. X plus 4 are not like terms, so we can't add them. So our first step would be distribute. And distribute. All right, and then add like terms. So we did D, now we need to do C, which is combine like terms. 6x plus 27 equals x. Ooh, this is a weird one. All right, so because there's an x here and an x here, we actually want to move the 6x first because the 27 is the only constant, so we want to leave that alone. So let's subtract 6x from both sides. That will give you 27 equals 1x minus 6x is negative 5x. And then divide by whatever's next to the 5. Same to the other side. And you get some weird looking thing that's 27 over negative 5. I could check that. Let's see, it's going to be an ugly check. Let me do it up at the top here. Let's see. 6 times 27 over 5, that's a negative 5, plus 4 plus 3 is supposed to equal negative 27 over 5. Okay, so I'm going to use my guy. Let's see, negative 27 over 5 plus how many? What is 4 as a something over 5? What is 4 as something over 5? This was times 5, so that was times 5, so that's 20. So this would be 25s. So this would be 27 minus 20 is negative 5 fives. Negative 5 fives is a 1. So 6, 3 is negative 27 over 5. This is not looking good. So I did something wrong. 27 6. I wrote it down right. 6 times x, 6x, 24, 3. Let me check. I got a key somewhere here. I do have the key, but I didn't check it, so. Oh, right up here, sorry, was a 7. See, this was a hard thing to check, I'm just telling you. Alright, so this was negative 7 over 5. So this was negative 42 over 5 plus 3. 3 as something over 5 is 15. So what is 42 minus 15? Yay, is 27. So negative 27 over 5 equals negative 27 over 5. Okay, so that is correct. Whew. Made a mistake checking. That is not an unusual thing. That's a hard checker. All right, so how about this next one? We've got, what's going on here? We have a d term, then another d term, and a constant term. So let's combine the d terms. A negative 6d plus a negative d is a negative 7d plus, plus a negative 8. That's weird. D plus 4. All right. Here, let me do that again. All right. Negative this d plus this d is negative 7d. I'm just going to put minus 8 equals d plus 4. All right, so d goes back over here and the 8 goes that way. So let's move the d. All right, and then move the 8. So I'm going to get a negative 8d equals 12. Negative 8, negative 8. So this is d equals negative 12 over 8. You reduce that by 4 and you get 3 over 2. Check my key. Oops. Okay, so I need to write out divide by 4. Wait a minute. Divide by 4. Divide by 4, I get 3 over 2. Let's see, what does the key say? The key says 3 over 4, which is wrong. Sorry about that. To divide the top by 4 and the bottom by 4, you should get a 3 over 2. Let me fix that on the key. Sorry about that. All right, moving on. All right, 2x over 3. 2x over 3 equals 4. All right, there's a couple ways to solve this. If you want to clear the fraction, let's just multiply by 3. That gives you 2x equals 12. I think that's pretty easy that way. So you get x equals 6. So that's easy to check, too. 2 times 6 over 3, which is 12 over 3, which is 4, equals 4. So that's good. All right, over here, how do we get rid of this? Negative 4 over 9x equals 2. There's two ways you could multiply. Let's just clear the fraction. I just think that's easiest. It really is, I think, the easiest way to go. Let's see. This number divided by 2 and this number divided by 2 is 9 over 2. Don't drop the negative. Let me check my key. Yep. Okay. All right. This guy is plus 5 plus 5. So this would be 4f7 equals 2. I want to clear my fractions. 4f equals 14. Divide by same. Divide by 2. This would be 7 over 2. That'd be hard to check, but that's what I got before. All right. Distributing a fraction. So a negative times negative is a positive. 1/4 times 4 over 1. Across the top would be a positive 4 over a positive 4, which is a 1. So I think that turns into an x. This one is positive 7 over 4 equals 3. Let me check my key. Oh, I cleared the fractions first. Let me keep going this way and then I'll check that way. That was probably a better idea. Let me just check. So this would be x equals, what is 3 as something over 4? 1, 4, 4 is 12. So that would be this, and that would be a 5 over 4. So let's check by clearing the fractions. Let's see, I multiplied that by 4 and that by 4. That's a 4, sorry. Because that's the only denominator I have. So you'd have a negative 1 equals, oops, not equals. You'd have negative 1 times negative. Remember, we don't clear the fractions in the parentheses because that would be double clearing. All right, distribute that negative 1 would be 4x plus 7 equals 12. Move the 7 over. 4x equals 5, or 4x equals 5 over 4. So either way, that works fine. And let's see, lots of stuff going over here. We have 5, 3 times, that's 3x. Distribute to both terms. We also need to distribute on this side. Negative 12, negative 15, minus 2. That 2 is not in the parentheses, so don't distribute to that. Combine like terms, so distribute, combine like terms. 32 plus 3x equals, let's see, these are the like terms. So the constants are like terms over here, constants like terms over here. Minus 17. Alrighty. Alright, now this one gets moved this way. This one gets moved this way. So this is going to be 15x equals negative 49. Check my key. Yeah, that's what I had before. All right, this is just... And, oops. And 15 is 3 and 5, and 49 is 7 and 7, so it does not reduce. So we're good.